Good day! Welcome to our online math tutorial, series of math lessons for grade 10. Tara, sabay-sabay tayong matuto at home. This is for grade 10 mathematics, quarter 1, module 3. It's all about arithmetic means and nth term of an arithmetic sequence. This is Teacher Marian M. Guerrero, your grade 10 math teacher for today. Before we start our lesson, please prepare the following: your math module, piece of paper, ball pen, and your notebook. In this lesson, you are expected to write a formula for the nth term of an arithmetic sequence, find the nth term or unknown term of an arithmetic sequence, define arithmetic means, determine arithmetic means of a sequence, and solve problems involving nth term of an arithmetic sequence. To begin our lesson, let us have an activity entitled What's Next? You have to find the common difference and the next three terms of each arithmetic sequence. Number 1. 6, 10, 14. First, we have to get its common difference. And to find the common difference, we can subtract the second term to its first term. 10 minus 6 will give us 4. Therefore, the common difference is 4. Using the difference, we can now add to get the next three terms. 14 plus 4 will give us 18, plus 4 is 22, plus 4 is 26. Number 2, 4, 14, 24. Again, for us to get the common difference, we can subtract the second term to its first term. 14 minus 4 is equal to 10. Using the common difference, let us use this to add in the last term of the sequence. 24 plus 10 will give us 34. 34 plus 10 is 44. And 44 plus 4 plus 10 is 54. Number 3. Negative 8, negative 6, negative 4. Subtract the second term to its first term to get the common difference. Negative 6 minus negative 8 is negative 6 plus 8, which is equal to 2. Thus, the common difference is equal to 2. Let us now add this common difference to our last term. Negative 4 plus 2 is negative 2. Negative 2 plus 2 is 0. And 0 plus 2 is 2. Lastly, number 4. Negative 10, negative 15, negative 20. Let us now subtract the second term to its first term. Negative 15 minus negative 10 is negative 15 plus 10, which is negative 5. Therefore, we should add negative 5 to get the next term. Negative 20 plus negative 5 is negative 25. Negative 25 plus negative 5 is negative 30. And negative 30 plus negative 5 is negative 35. Now, what about if we are required to the 100th term or the 250th term, given the first term and the common difference? How can we find the terms? To answer this, let us continue our lesson. For this lesson, we will discuss about the nth term of an arithmetic sequence. Let us investigate on how to determine the nth term of a sequence. We can determine the pattern using a tabular form. Example, find the nth term of the sequence 3, 8, 13, 18. Investigate the pattern below. The first term is 3. The pattern is just 3. The second term is 8. And 8 is obtained by adding 5 from 3. That is 3 plus 5. And can be written as 3 plus 5 times 1. The third term is 13. 13 is obtained by adding 5 to to the last term. Thus, it makes 3 plus 5 plus 5, which can be written as 3 plus 5 times 2. And the fourth term is 18, which is obtained by adding 5 from the last term. Thus, it makes 3 plus 5 plus 5 plus 5, which is 3 plus 5 times 3. Whereas, if we are about to get the nth term of the sequence, that is a sub n, that is 3 plus 5 plus 5 up to the last 5, depending on the number of terms. Therefore, the pattern will be 3 plus 5 times n minus 1. Taking a look, a sub n is the term of the nth position, and 3 is our first term, and 5 is our common difference. Therefore, we can say that a sub n is equal to a sub 1 plus d times n minus 1, and that is the formula for our arithmetic sequence. Now, the nth term of an arithmetic sequence is given by a sub n is equal to a sub 1 plus d times n minus 1, where a sub n is the term that corresponds to nth position, a sub 1 is the first term, and d is the common difference. Let us have our first example. Find the 21st term of the arithmetic sequence 6, 9, 12, 15. First, we have to identify the given. We have our a sub 1, or the first term, is 6. Our common difference is obtained by subtracting the second term to its third term. 9 minus 6 will give us 3. And since we are looking for the 21st term, thus n is equal to 21. Then, using the formula, we substitute these values. Our formula is a sub n is equal to a sub 1 plus d times n minus 1. Our a sub n will become a sub 21, a sub 1 is 6, our d is 3, and our n is 21. Simplifying the operation inside the parentheses, 21 minus 1 will give us 20. Then, let us subtract 3 and 20. This will become a sub 21 is equal to 6 plus 60. And lastly, adding 6 and 60 will give us 66. Therefore, the 21st term of the sequence is 66. Next example, in the arithmetic sequence 7, 10, 13, 16. Find n if a sub n is equal to 304. For this problem, we are looking for the position of 304, which is denoted by n. Given, we have the first term a sub 1 is equal to 7. The common difference is obtained by subtracting the second term to the first term. 10 minus 7 is 3. And our a sub n, which is 304. We are looking for n. Using the formula, we substitute these values. A sub n is 304, a sub 1 is 7, and d is 3. We are looking for n. Now, distribute 3 to the terms inside the parentheses. We have 304 be equal to 7 plus 3 times n is 3n, and 3 times negative 1 is negative 3. Then, let us combine like terms. This will become 304 is equal to 3n plus 4, wherein 7 minus 3 will give us 4. Next, to eliminate plus 4, we can subtract to each side minus 4. So 304 minus 4 is 300, and 3n plus 4 minus 4 is just 3n. And then, let us divide 3 to both sides of the equation. We will come up with n is equal to 100. Therefore, 304 is the 100th term of the sequence. Next, Example number 3. The third term of the sequence is 8 and the first term is 2. Find the common difference. Given, a sub 3 or the third term is 8. N is equal to 3, which is the third term. And a sub 1 or the first term is equal to 2. We have to find the common difference. Using the formula, we substitute these values. A sub n is equal to 8, a sub 1 is equal to 2, and n is equal to 3. Simplify. This will become 8 is equal to 2 plus d times 2 because 3 minus 1 is 2. Then multiply. We have 8 is equal to 2 plus 2d. Then subtract 2 to each side of the equation. 8 minus 2 will become 6 and 2d plus 2 minus 2 is 2d. Then divide both sides of the equation by 2. Therefore, the common difference will be equal to 3. Example number 4. After 1 second, a rocket is 30 feet above the ground. After another second, it is 85 feet above the ground. Then after another second, it is already 140 feet above the ground. If it continues to rise at this rate, how many feet above the ground will the rocket be after 16 seconds? In this problem, we can write this in a sequence. Whereas, after 1 second or a sub 1, that is 30 feet above the ground. After 2 seconds, 85 feet above the ground. After 3 seconds or a sub 3, 140 feet above the ground. Therefore, after 16 seconds or a sub 16, what is the height of the rocket above the ground? Now, let us state the given. Our first term is 30. Our common difference is obtained by subtracting the second term to the first term. 85 minus 30 is 55. And n is equal to 16 since we are looking for a sub 16. Now, using the formula, we substitute these values. A sub n is 16, a sub 1 is 30, common difference is 55, and n is 16. Simplify. 30 plus 55 times 15. Multiply. 55 and 15 will give us a sub 16 is equal to 30 plus 825. Then, we will come up with a sub 16 is equal to 855. Therefore, after 16 seconds, the rocket is 855 feet above the ground. Now that we are done in our lesson for the nth term of an arithmetic sequence, let us now compute the arithmetic means. The first and the last terms of a finite arithmetic sequence are called arithmetic extremes, and the terms in between the extremes are called arithmetic means. Meaning, in the sequence 4, 8, 12, 16, 20, 24, 4 and 24 are the arithmetic extremes, while 18, 12, 16, and 20 are the arithmetic means. The arithmetic mean between two numbers is sometimes called the average of two numbers. For example, the arithmetic mean between 4 and 12. It is the average of the two numbers. 4 plus 12 divided by 2, which is equal to 16 divided by 2, which is 8. Therefore, the mean between 4 and 12 is 8. 4, 8, 12. While, if there are more than one arithmetic means will be inserted between two arithmetic extremes, we use the formula to get the common difference. So from this, we will obtain the formula for the common difference. Simplifying, our common difference will be equal to a sub n minus a sub 1 all over n minus 1, wherein a sub 1 is the first term. We can write it as a sub k, and 1 could be k. D now is equal to a sub n minus a sub k all over n minus k. For example, insert 3 arithmetic means between 8 and 16. 8 will be our first term, and 16 is our fifth term. We will be looking for a sub 2, a sub 3, and a sub 4. First, the given, our a sub k is equal to 8, or the first term, wherein k is equal to 1. And the last term, which is a sub n, which is 16, wherein n is equal to 5. Using the formula, substitute these values. D is equal to a sub n minus a sub k all over n minus k. This will become 16 minus 8 all over 5 minus 1. And 8 divided by 4 will give us 2. Thus, the common difference is equal to 2. We can now get the second, third, and fourth term using the common difference and add it to the first term. To get the second term, that is a sub 1 plus 2, which is 8 plus 2, which is 10. Then, the third term, 10 plus 2 is 12. And the fourth term, 12 plus 2 is 14. Thus, the three arithmetic means are 10, 12, and 14. Example number 6. Find the missing terms of the arithmetic sequence. We are missing the first term, the third term, and the fourth term. In this sequence, the given a sub 2, which is equal to 6, and k is equal to 2. Then a sub 5, or the last term, is equal to 30, and n is equal to 5. To find the common difference, use the formula and substitute these values. This will become d is equal to 30 minus 6 all over 5 minus 2. 30 minus 6 is 24, and 5 minus 2 is 3. And 24 divided by 3 is 8. Therefore, the common difference is 8. For us to get the first term, we will subtract 8 to the second term. 6 minus 8 is negative 2. And for us to get the third term, we will add 8 to our second term, which is 6. Thus, the third term is 6 plus 8, which is 14. And the fourth term is 14 plus 8, which is 22. Thus, the missing terms of the arithmetic sequence are negative 2, 14, and 22. Now, we are done with our examples. Let us summarize our lesson from today. The nth term of an arithmetic sequence is given by a sub n is equal to a sub 1 plus d times n minus 1. And to find the nth term or unknown terms of an arithmetic sequence, we substitute the given values to a sub n is equal to a sub 1 plus d times n minus 1. The terms in between the extremes are called arithmetic means. And we use the formula d is equal to a sub n minus a sub k all over n minus k to get the common difference of two non-consecutive terms and determine its arithmetic means. That is all for today. Thank you for listening.